This video is on how to prove lines are parallel. So first, let's talk about what we have when we have parallel lines. So some angle relationships you probably remember include alternate interior angles. So those are very commonly used because they are congruent. So some alternate interior angles you see here are 3 and 6. Again, we say alternate because they're on opposite sides of the transversal, but they are inside those parallel lines. So alternate interior angles. So 3 and 6 are alternate interior angles, and 5 and 4. So those are extremely helpful when we're trying to prove parallel lines, because if we are given congruent alternate interior angles, then we know those lines are parallel. Another angle relationship that comes up quite frequently are corresponding angles, which we also know are congruent. And those are angles that are in the same position. So what I always say is if I was to cut out this piece here and lay it on top of this piece here, which angles would correspond to one another or fall on top of one another? And we see that angle 1 corresponds nicely to angle 5. Angle 2 corresponds to angle 6. Angle 3 corresponds to angle 7. And angle 4 corresponds to angle 8. So when I say corresponds, like angle 4 is in the bottom right-hand side of that intersection, and so is angle 8. Same position. So if we take a look at our interactive notebook page, proving lines parallel, we see that we are given this unbelievable given that those two triangles are congruent to one another. Now that is, in fact, unbelievable because I can say that any of their corresponding pieces are congruent using CP/CTC. Their corresponding sides, corresponding angles. So let's go ahead and start by just writing down that given. So statement 1, we know that triangle ABC is congruent to triangle CDA. And that's given. Now, if I look at what I want to prove, I want to be able to prove that those lines are parallel. That means I want one of those angle relationships that we had just described on the last few pages, as well as any of the other ones that you know. I only mentioned alternate interior and corresponding because they're the most common, but we know there are several others that exist as well. So what's really important to remember here is the two lines are actually trying to prove parallel, and that's AB and DC. So if you want to use any kind of notation, let's make sure we mark these as parallel with our arrows, because that's what we want to show. They're not parallel yet, but we want to show that. I like to use alternate interior angles whenever I can, and it looks like in this case I can easily. So I'm looking for that Z. So again, I can make that Z with those parallel lines, or those lines I want to show are parallel or prove are parallel. And then I see it's these two angles that I want. And I can actually say those angles are congruent because I know the triangles are congruent, right? So because the triangles are congruent, I know any corresponding angles are congruent. So let's see. So statement number 2. I can say angle BAC. So angle BAC, which is this angle here, is congruent to angle DCA, which is this angle here. And the reason is CP/CTC. And I'm going to write it out because more often than not, we make mistakes when we say CP/CTC. So I want to make sure we understand what we're really saying. We're saying that corresponding parts, and part stands for angle sides, of congruent triangles, which we already have, are congruent. So just to make it really clear, this is where the CP/CTC comes from. CP/CTC. Of course, you can just write CP/CTC, but if you mess up those letters, you do not get full credit, so be very cautious. So this is really a big deal. Now that we know that those angles are congruent, we have alternate interior angles, which means I can actually prove that those two lines are parallel. So for statement 3, we're going to say that AB is in fact parallel to CD, or DC, I'll put. And the reason is, it's the opposite of when we're given parallel lines. So if two lines are cut by a transversal, and their alternate interior angles are congruent those lines are parallel. So this is a really long statement, I will give you that, or a reason rather, but I want to just point out that it's the same every time. The only thing that's going to change here is the alternate interior angles, because it depends on which angle relationship we're looking for, and the fact that they're congruent, because of course we can use supplementary in some cases as well. So this is it. This is proven. I proved that they're parallel. So the goal here is to get an angle relationship, then you can say they're parallel. So you want to get one of that relationships you know is true when two lines are parallel, then you can state that they're parallel. And this down here, you don't actually have to fill it in. This is just to let you know, it's like this scaffold that we had for reason number 3. If two lines are cut by a transversal and they're blank are blank, then those lines are parallel. So you're just gonna, this is really like you're filling the blank depending on what the proof gives you at that time. So I just wanted to show you an example because this is really like a very straightforward, very basic example. So I thought we should do one more just to maybe drive the point home, okay? So this is in our packet, and this is also asking us to prove that two lines are parallel. It wants us to show that AB is parallel to DC, so this is our goal here, right? That those two lines are parallel, and it gives us some other information. It gives us that AD is congruent to BC, right? And then it gives us that, AD is congruent to BC, and then it gives us that AB, let me start over. It gives us that AD is congruent to BC, and AB is congruent to DC, okay? So I have those opposite sides being congruent. I'm sorry if the letters are confusing. So I have some sides there, which is great. So let's think about this. I have some one and done givens, which means if I start with number 1, and I say that AD is congruent to BC, that's given. And I love that as a given because it's automatically giving me a side, right? It's a one and done given. Then if I go to my second given, which is that AB is congruent to DC, that is also given, and that is also glorious because that is giving me a side. Now at this point, you may not really be sure how to prove that they're parallel, but you should recognize that you can get the triangles congruent, right? And our goal should always be to get the triangles congruent, because once you have the triangles are congruent, the possibilities are endless. And you can prove them congruent using the reflexive property, right? So our statement number 3 is going to be that DB is congruent to DB, and that's the reflexive property. And now I know that these two triangles are congruent by side, side, side. So this was my last side. And now I can say, all right, I know that triangle ABD is congruent to triangle CDB. And the reason for that is side, side, side is congruent to side, side, side. So whenever I can get the triangles, I should get the triangles. Now I have everything I need. I have unlocked the wonderful world of CP/CTC, and now I just have to think to myself, well, what do I want to get in order to prove those two triangles are, those two lines are parallel? And I really love those alternate interior angles. So again, you guys should see that if I connect this line here, I do have my Z. So I really want this angle is congruent to this angle, and that'll give me those alternate interior angles again. And I know that those angles are congruent because corresponding parts of congruent triangles are congruent. So let's go ahead and write that in, okay? I know that statement number 5, I can say that angle ABD is congruent to angle CDB, and that's because of, I'm going to actually write it this time, CPCTC, corresponding parts of congruent triangles are congruent. And now I can actually state that those two lines are parallel. AB is parallel to DC. And the reason for that is that long-winded reason, but again, it's a lot of words, but it is very straightforward. If two lines are cut by a transversal, and their alternate interior angles are congruent, then those lines are parallel. So this is it again. I was able to prove that they're parallel. Remember, unlocking those congruent triangles is a big deal because it unlocks a world of possibilities to you. And all you need is one of the angle relationships. You need alternate interior, alternate exterior, corresponding, right? Once you have one, then you can say that they're parallel because that relationship exists. If you have any questions, you know where to find me.